In this lesson, I'll show you how to graph a hyperbola that's in expanded form. The question reads, graph the equation shown on your screen. In order to graph a hyperbola that's not in standard form, you actually have to convert it into standard form. In case you're confused, this is what a standard form hyperbola looks like. So we have to change this so that it looks like this. And in order to do that, you need to complete the square. And you have to complete the square twice. You have to complete it for the x terms, and you have to complete it for the y terms. So let's go ahead and do that. And given that this question is very lengthy, make sure that you have enough paper as you follow along. To complete the square, you have to group the x terms and the y terms together, and that appears to be done already. Notice. In addition, the coefficient in front of the x squared and the y squared term need to be 1. So I'll factor out a 4 here and a negative 9 here. Factoring out a 4 between these two, I end up with 4 bracket x squared minus 6x. Now I'll factor out a negative 9. This gives me y squared plus 10y. And this constant will be taken over. And the reason why is because we want it to have a constant on the right side. Notice that it's 1. The next step is to take the x and the y term individually and divide it by 2, then square it. Let's start with negative 6. Negative 6 divided by 2 is negative 3. And we'll square this. This gives us positive 9. Similarly, taking the 10 and dividing that by 2, we end up with 5. Squaring that gives us 25. I'll take this plus 9 and add it and subtract it to the expression that's within the parentheses, and similarly the same thing here. I'll take plus 25 minus 25. So our expression now should look like this. The next step is to take this negative 9 outside of the parentheses and this negative 25 outside the parentheses. So this needs to be removed, and so does this. But to remove this negative 9, you first have to multiply it by the factor outside. So negative 9 times 4 is negative 36. And that's a constant, so we'll take that negative 36 to the right side. Taking a negative number to the right side makes it positive. So we'll write down positive 36 here. Similarly, negative 25 times negative 9 is positive 225. Taking positive number over makes that negative 225. So our expression now should look like this. 4x squared minus 6x plus 9. This is a perfect square trinomial. Minus 9y squared plus 10y plus 25, also a perfect square trinomial, is equal to these three numbers combined, which if you use your calculator should give you negative 36. Now the importance of having a perfect square trinomial is that it's easily factorable. What two numbers multiply to 9 and add to negative 6? Well, if you recall, that number is negative 3. What two numbers multiply to 25 and add to 10? That number is 5. So this expression becomes 4 bracket x minus 3 squared, and this part becomes negative 9 bracket y plus 5 squared is equal to negative 36. Now if you take a look at the standard form equations, you have your x and your y terms over a number, generally a and b. To convert this so that it looks like that, I'll divide everything by 4 first, and the reason why is so that this 4 will go away, and divide everything by 9 so that this 9 goes away. So this 9 cancels out, leaving us with x minus 3 squared over 9 minus y plus 5 squared over 4 is equal to negative 36 over positive 36, which is negative 1. Now, according to the standard form equation, 1 needs to be positive. In our case, it's negative, so I'll multiply this whole equation by a factor of negative 1. That makes this positive, and this negative. We're done. We have finally converted the expanded form hyperbola into one that's in standard form. And the reason why this is important is because now we can easily identify the center at which this hyperbola lies. The center will be at positive 3 and negative 5. Therefore, the center we can graph now at positive 3 and negative 5. That's right there. Also, another reason why the standard form equation is important is because now we can also identify where the transverse axis will be, whether it will be on the horizontal or on the vertical. And the way you can tell is by looking at which of the variables, x or y, is negative. If the y variable is negative, as you can see, then your transverse axis will be horizontal, so it will open up like this. If your x is negative, then it will open upwards. Let's take a look at ours. Here y is positive and x is negative, so ours will open up vertically. The transverse axis is vertical. Let's document that underneath. Now that we found out the transverse axis, we can go ahead and start to plot this. The next thing that I'll do is assign this as my b value and this as my a value. Notice that the a value is underneath the y and the b value is underneath the x. And what these numbers will give rise to are my transverse and conjugate vertices. So b represents the conjugate vertices, and if we square root 9, we end up with plus minus 3. And if I square root 4, I'll end up with plus minus 2. Now b represents the conjugate axis. So our conjugate axis from the center will be 3 units this way and 3 units this way. So our box will be the length from here to here. This point is 6 and negative 5, and this point is 0 and negative 5. What a tells us is the transverse axis vertices. So if I add plus 2 up and plus 2 down, I'll end up with 3 and negative 3, and this being 3 and negative 7. And the reason why this is important is because I'll now create a box along these dimensions. This represents one of my vertices, and this also represents one of my vertices. So I'll put a dark dot here and a dark dot here. This is my transverse vertices. Next, I need to find my asymptotes. And the asymptotes will help guide me create my two curves. I already know that this is going to open up like this, and that's going to open up like that. But I want a guideline so that I don't open it up too much or too little. And that's where the asymptotes come to play. To find the asymptotes, given that its transverse axis is vertical, notice what's in orange. That's the transverse axis. I'll take my a value and divide it by my b value. My a value was plus minus 2, and my b value was plus minus 3. So our asymptote equations will be y is equal to plus minus 2 over 3x, and this is only the case if it were centered at the origin. Ours is not. So I'll replace this y with y plus 5. Y plus 5 is equal to plus minus 2 over 3, and my x was x minus 3. Rearranging for y, I'll end up with y is equal to plus minus 2 over 3 x, and I'm multiplying this inside. If it's plus, it's going to be plus minus 2, and then bringing that 5 over makes it negative 5. So I have two equations. Y is equal to 2 over 3x plus 2 minus 5, and y is equal to negative 2 over 3x minus 2 minus 5. Combining these, we get, now that we have our equations for the asymptotes, I can go ahead and predict that if you graph those two equations, you'll have two lines that go like this. Notice the lines in blue, they cross the corners of this box that we created. And this also tells us that we need to widen the curve like this. Make sure that it doesn't touch the blue line, because the asymptote serves as our boundary. Before we conclude, as a final touch, you can also find the focus points, and you're going to have two. So you'll have one focus over here in this region and one over here. To do that, we'll use the formula c squared is equal to a squared plus b squared. We already know what our a and our b are, so this won't be hard to do. We have 2 to the power of 2, that's 4. And 3 to the power of 2 is 9. So we have the square root of 13. Let's find out what that is. The square root of 13 is approximately equal to 3.6. Of course, keep in mind that this number is plus minus because we're square rooting a number. Now what this is telling us is to find the focus in this region, we'll take 3.6 and add it to the center, which was at -5. So we have -5 plus 3.6, and we keep the x-coordinate the same. So adding these two together, we should end up with a number over here. And to find the focus in this region, we take -5, which was the y-coordinate of the center, and we subtract it to 3.6. Whatever the sum and difference of these numbers are represents the y-coordinate of the foci. And there you have it. That is how to graph a hyperbola in expanded form.